right, good morning. How y'all doing? All right, woo, yeah. Thank you very, very much for being here. Hopefully, how many of y'all, this is your first session of reInvent? Oh man, y'all are nuts. All right, I appreciate that. I'm super excited you're here. Let me get this big old thing here. Don't look. Okay, here we go. So we're talking about building advanced workflows with AWS step functions. All right, if you're in the wrong room, you should stay. We're going to have some fun. So, and that's all I'm going to say about that. So, a little bit about who I am. My name is Eric Johnson. I'm a principal developer advocate at AWS. I'm a serverless geek. I've been doing serverless since the day they announced it. I remember looking at it and go, why would you do it any other way? Now, this particular presentation I'm going to give today, I'm going to give a shout out. I don't think he's in the room, but he's here this week to Ben Smith. Ben Smith actually was our step functions guru. We're all step functions gurus, but he was like the guruist of us all. And he walked through this, and he's not with AWS anymore, but he's still very much involved in the serverless. So shout out to him. So this is based on a lot of what he did, and obviously some of my own stuff, and we'll have a good time. So real quick, how many of y'all, first of all, I just want to say hi to everybody in the room, and we've got some overflow rooms that are happening. Hi there, and anybody watching later, super glad you took the time to watch this. How many of y'all have seen me speak before? Okay, so a good amount of you, but not enough of you. So of course, I have to give the rules, all right? Okay, so there's a couple of rules when I'm talking, and you may think I have no power to give rules, but I do have the mic, and even without the mic, I'm the loudest in the room. But these are the rules just to help you out. First of all, this is any number I want it to be, okay? I'm gonna hold it up, and I may say 7. I have 5 kids. I want a table for 20, and it's any number I want it to be. Right? It never fails. I'll say, table for 10, and I'm sitting alone at the bar somewhere. So they figured out. These are quotes, not apostrophes, right? Because this just looks stupid, okay? And somebody in the back is like, is he doing a bunny? So I'm not doing a bunny, unless, of course, I am, right? And finally, these are thumbs, because I guarantee you this will get you beat up, okay? So hopefully that helps you out. I do like to make a lot of one-finger jokes. I was born this way, not for the first day this morning, or I would not be here with you. I was born this way. I'm very comfortable with one-finger jokes. However, and I'm really serious about this, if that makes you uncomfortable, I'm also comfortable with that. So I'm good either way, and so let's have some fun, all right? So like I said, Eric Johnson, I've been doing technology forever, and some of it good, some of it bad, but serverless has been the good. I've really enjoyed that. All right, so let's jump in. We're going to talk about AWS step functions today. How many of y'all are using step functions now? All right, good, okay. Good. So hopefully a lot of what I'm saying you already know. Hopefully I teach you something new. How many of y'all are looking to just get started with step functions? Okay, all right, so this is a 400-level session, so I'll be talking about some things you're like, I'm not sure what that is, but I have some resources at the end where I'm going to point you and say, hey, here's where we want to learn about some more. But it's still a good session. You can get some concepts, things like that. All right, so let's look at our agenda today. Super cool idea here. We have the agenda as a step functions workflow. Woo, that's right. This is Ben's idea. I can't take credit for this one. I was like, I'll leave it and take credit, but everybody knows I wouldn't. So, all right. So today we're going to be talking about step functions first. What does that mean? Why do we say that? We're going to be talking about which workflow type should you use, standard or express. We're going to talk about reducing costs, always a big winner. That's one of those where you're like, it's not an exciting story, but everybody wants to know. When you start paying the bill, it's like, how do we reduce that cost? And there's some really interesting things you can do with step functions to build them efficiently. We're going to talk about improved data flow. Hopefully you've been watching. We've had a few announcements go on. And then we're going to talk about managing failure and step functions at scale. I have a lot of content to cover, so it might be less jokes than usual, but we're gonna cruise through this. All right, so when we talk about serverless, kind of an interesting way to look at this is like this serverless pyramid, right? And we have this, some is manual, like you have ECS Fargate, where that's serverless, but you have some controls and some knobs and levers you can turn. And then you get all the way up to like EventBridge or Lambda functions, where it's not as many knobs and levers. But the idea is you have these services that we chain together to build applications. Right? A really cool term that Ajay Nair has said, and I've taken and run with it, is this idea of service full. Right? I don't think he coined it, but that's something. And the idea, again, is building applications with services. So the last thing you do is code. Wow, I made a really slurpy sound on the mic. That's going to be fun. Okay. So, if you listen to me, I'm going to talk a lot about how bad code is. It's not bad. Only Eric Johnson's code is bad, okay? And there's a couple of people in the room, and I'm not going to point Matt out right there, but have worked with me and know my code is bad, right? Darren's right next to him, and he knows that as well. My code is a liability. There's just no two ways about it. So if I can do configuration, that's better. And really, my mantra is code should be, if all else fails, then code. Now, I know you're a bunch of developers. You're like, I can write the next best, the next greatest authentication systems because we need another one, right? But sometimes it's better to use the services that are already there. And that's what we do with these serviceful applications. But the question comes up is when your application is powered by multiple connected services, how do you build, track, inspect, visualize, and orchestrate these connections, right? You have a lot of stuff going on. You need to say, do this first, then do this. How do we do that? Well, my friend, I'll tell you, this is the answer, AWS Step Functions. Now, again, this is a 400 level. Most of you raise your hand, but just for those of you who are getting to know it, this is, AWS Step Functions is a pay-per-use. It is what you're looking at is a Visual Workflow Studio here, and it is a Visual Workflow service where you can actually build, drag and drop, how you want your application to run. Do this, then do this. Now do these things at the same time. If this, then do this. You have logic, you have flow. There's a lot of things that work in this. And you can use the drag and drop, or we have a markup language called ASL, that's Amazon States Language, to help describe this. And you have built-in error handling. This is where it gets really cool, is this built-in error handling, built-in if it doesn't work, all kinds of things. And it integrates with over 200 services. Meaning, we actually use the SDK under the hood, so if you're in your code or using SDK to talk to a service, you can do that directly in Step Function. Super powerful. I remember when they told me about this, when we released this a couple of years ago, and they were showing it to me beforehand, and I was like, somebody gets a raise, because this is genius level, right? Right. So we have this idea of step functions first, step functions always. Now, this is an interesting phrase that if you know the name Rob Sutter used to be one of our DAs, and years ago he said this, and I pushed back. Rob, I don't know if I want to use step functions for everything. Because at the time, step functions didn't have synchronous invocation. But now that it does, I'm on board. Ben Smith said this last year. I'm saying it this year. I probably said it last year as well. Step functions first. And I'm going to show you kind of why this makes sense. So we have this example application, real simple, we've probably all done it, where we're going to talk to DynamoDB. We have a Lambda function that's going to call DynamoDB, and to do this, you have multiple lines of code, right? You're going to create your client, you're going to create the parameters to talk to DynamoDB, you're going to then create the function, the async function to query that, and then finally your Lambda handler. And this is okay. I mean, this is a very acceptable, I'm not pounding on this, but how would you do that in step functions? So even a single task workflow in step functions can make sense. And I'll show you why. With this, you have the ability, right? So I have this get item in step functions where I'm going to say get the item, which is the same thing I'm doing in the Lambda function, but I'm orchestrating this. And what can happen is if it can't get the item, then I tell it, try again. I don't have to code for that. I just say try again. And if it's tried again multiple times and still can't get the item, then we got to go to a DL queue, dead letter queue, and we handle that data. Now, you can do this in a Lambda function as well, but you got to write the code for it. And remember, Eric Johnson's code is a liability. And I'm not the only one, right? So again, it's this, if you don't have to, why should you, right? So this is what this would look like in an actual step functions. DynamoDB, you would have the SQS, and then you would fail it and say, hey, it's not working. You get the errors back. And the cool thing about that is you can drill down and trace what those errors were. Hey, when I tried this, this is what went wrong. This is where I failed. This is where my configuration failed, right? The second thing is you can take a look and examine the input and the output of the step function. Now, this is pretty basic stuff at a 400 level, but I want to make sure everybody's kind of with me on this, right? So your error handling's built in, your input and output are there, and so all that's right in step functions, and here you go. That's right out of the box, right? All right, so we're going to talk about our first pattern. We're going to build up to it here. We're going to look at breaking apart the Lambda lift. Now, when we're building applications in Lambda, we've gone this huge pendulum of, everything this application ever does, an entire app, I'm running WordPress from inside a single Lambda function, right? Anybody guilty? Anybody guilty of trying? Okay, there's a couple. It's like, yeah, I did that. I didn't do it, I successed. Successed? I just made a new word. That happens. All right. And then we went the other way where we say for every method on every resource, I'm going to have a separate Lambda function. And so then we built, 3 million Lambda functions to have a to-do list, right? So that gets a little crazy, right? So we go back and forth, but what we're looking to do is to kind of break this down. Now, the thing with building an API in a Lambda, when we do this, hey, one Lambda does it all, we're going to proxy it through API Gateway, whatever comes in past this Lambda function, and you're going to have, so in this example, we have create, update, and delete, and the Lambda function does all that. But when we do this, for those of you who are security-minded, which should be everybody in the room, security permissions are applied to the whole, right? This Lambda function can do everything based on what it's doing, right? Performance settings are applied to the whole. Duration and space limits are applied to the whole. You're applying single permissions and settings to just one Lambda function that's doing a lot of things, right? And so that's not necessarily best practices, and that's not the smallest blast radius, right? I don't know if that applies, but I really like saying that word, so there you go. All right, so let's break this apart. So we can actually say, okay, you know what? I'm going to actually create a different Lambda. This isn't per method, but we're going to build domain-specific Lambda functions, right? We have one for create, we have one for update, we have one for delete. Now we've got 3 different lines of code, or different pages of code. Again, this isn't wrong. I'm a huge fan of Lambda functions, but I can also do this, and what I'm going to show you is the next pattern, and this is called the REST easy pattern, okay? Probably not really. Ben made these names up, I kept them. I don't think we've gotten them out in public as much as we want to, but if you would call it the REST easy, that would be great. And then tell them where you got that from Eric Johnson. So in the REST easy, what happens is you can connect an AWS or an Amazon. How you doing, Eric? They pay me to speak here at AWS. It's shocking. So Amazon API Gateway, you can connect it directly to step functions, and then that can say, okay, what method is it? Well, it's a get, all right? Follow the get path. It's a put, it's a patch, whatever, right? So you can build those straight into step functions. Now, how many of y'all have had serverless espresso coffee? Oh, the rest of you disappoint me. I mean, I love you, but I'm disappointed right now. So I feel like I'm talking to my kids. So serverless espresso, if you've not heard of it, is this booth we run all over the world where you can get free coffee. If you're in the certification lounge today, go get some free coffee. That's the serverless espresso running that. If you're in the expo hall later this evening, go get some free coffee. Tell them Eric sent you. It'll get you free coffee. It would get you that anyway. But when we first built this, we built this several years ago, we built it to use, much like what we're talking about, this kind of Lambda function-driven application where we had a Lambda for cancel, we had one for complete, make, create, and so on. And we really looked at this and said, we feel like we can do this in a more orchestrated way. Because the truth of the matter is the Lambda functions weren't really doing business logic. They were doing routing. And Ajay Nair had said, he used to be the director of Lambda, and I referred to him earlier, he said, Lambda should be used to transfer data. It should be used to transform data, right? So there's a big difference, right? So by using this, we switched in our version 2, we actually have one workflow that runs these for each coffee order. We can say, okay, is it a customer order? Is it a cancel order, complete order, so on. You can see how it routes through the system here. So again, it's this idea of step functions first, step functions always. If you're building something that has orchestration and you need error handling and you need retry, step functions is your go-to. And if you're building an application without error handling and retry, well, then I don't want to know you, right? Because that's really important. I do want to know you, but it's just to tell you, hey, do it right, okay? So now, when we look at this, like I said earlier, we talked about choosing the right workflow, right? So there's 2 types of workflows. We have the standard and we have the express. Right? So looking at these, they're a little bit different. Standard came out first, express came later. Standard has long-lasting wait times, so you can actually have a standard in invocation for up to a year, which is crazy. So if you're doing some manual input, things like that, standard's the way to go. It has asynchronous, and it guarantees it exactly once delivery, exactly once invocation, right? Whereas express, it's designed for high throughput. It's cost effective. It has an at least once, and there's some changes in that wording. Only once and at least once, right? And then it has synchronous or asynchronous, and it's designed again for short duration. These can last up to 5 minutes, and they run in memory, which is a really interesting thing, because there's no cold start on these. They run in memory, and they're very fast. So again, these start with step functions. All right, so let's look at comparing these, and we're going to give you a real-life example. So we built this e-commerce workflow, and we're going to run 1,000 as a standard, and we're going to run 1,000 as an express, right? And we created a CloudWatch dashboard so we could look at the metrics and see how that works. All right, so we go into this. When we run these per 1,000, standard cost us 42 cents to run 1,000 of these. Express cost us 1 penny. I can do one. I can actually do 4, but I have to take my shoes off. It gets weird. But here's 1. All right, so it costs us 1 penny, right? So let's break this down and look at the cost. So we're going to talk about the total cost for a standard workflow. Now, when you're looking at a workflow, it's about the transitions. How many transitions do I have in a workflow? So you're going to have the transitions times the number of executions, right? So the 1,000 executions times 0.000025, or 2.5 cents per 1,000, right? Because I'm moving the decimal, I think. I'm not a great math person, but. Okay, so we have 17 transitions. So as we go through this, your total cost is 17 times 0.025, which equals 42 cents. The total cost is 42 cents per 1,000, and that's where we get that, right? So on the Express workflow, this is based on the number of requests and the duration, all right? So again, we still have our 1,000, but the 17 doesn't really matter as much. It's the request itself. All right, so we're going to say the execution cost plus the duration cost times the number of requests. And the duration cost equals execution duration in milliseconds. Ooh, hey, almost lost that, over 100. There's the memory cost. And then the memory cost in step functions it's kind of a sliding scale. It looks like this. So 64 meg, you have your first 1,000, you have your next 4,000, and so on. Our actual running is in the 1,000. It's actually 64 meg. So it's 0.000, a bunch of zeros, and then 1042. Right? So we break that down. So we look at the cost here, and that's how we get the 1 cent. So again, on our comparison, 42 cents for 1,000 in standard, 1 cent for 1,000 express. And you're like, okay, I can handle 42 cents, but let's crank that up to 1,000,000. Okay? So now we're looking at $420 in standard and $12.77 in express. Let me make that chart a little bigger so you can see that, right? So now the powers that be are like, hey, let's do that differently. Let's see if we could drop that down. And you might be asking yourself, okay, so I have these two, one's standard, one's express. Why would I choose standard? And there are some important reasons why. Standard's a very, very viable product, right? So the first is if your workload takes more than 5 minutes. That's critical, right? You have to do standard. If the workload uses callbacks, and if you don't know what that is, we'll get into that in a little bit, but if you want to use the callback, you need to have the standard. And finally, the workload requires exactly once execution, right? So if item potency is important, and it usually is, it isn't always, then you want to look at that. And we have this cool step function here that shows the options on the side. Okay. Well, I asked the question, how about both? Right? So now we're going to get into some kind of features where we can work with these. And I'm going to show you a pattern. We call this pattern the nester, right? And so this allows you to actually create nested workflows that combine the workflow types to optimize for cost. All right? So we're going to use the same one to kind of walk through it. So what if these sequences, so we're going to look at our standard, okay? What if these sequences sometimes took longer than 5 minutes, right? The workflow, we're required to have a standard, right? But there's some particular parts of this that are doing some things that we might be able to change. So first of all, we've got some checking we're doing. We're looping to check, so we don't know how many transitions are going to happen there. But we're looking to see a status from DynamoDB. We're doing it 2 different places. And we also have this series of Lambda functions that we're running. And these Lambda functions are just going out and doing things. They're updating data, right? So those are the first things we're going to concentrate on. And this is where we can look at nesting these outside of the step function. All right, so what we do here is we say, from our standard, let's invoke an express that invokes these Lambda functions. So we've just removed 3 transitions, 1, 2, 3 between them. There you go. So we move those out. So let's look at what that does to the cost. All right, so we're back to our standard. This is the cost for doing a nested. So the cost of the parent workflow, we now have 14 times 1,000 times 0.000025 equals 30 cents. So we've cut 12 cents off right there. Now you're like, 12 cents, but 12 cents when we're talking millions, right? So this is huge, okay? So you have the number of states transition changed, and the cost there comes out to, and so the nested comes out to 0.0, it's not even a penny, right? So it doesn't even really, unless you run tons of them, doesn't really affect the cost. So we've brought this down 30 cents, or brought this down 12 cents to 30 cents there, okay? Look at the average duration, these are the different things. There you go. All right, so let's get more into reducing costs. We kind of explained what that does and kind of doing that pattern of the nester. So there are some more things we can do to reduce this cost, right? So to really understand this, you have to understand the standard is, again, priced on the state transition. So we want to reduce state transitions, what we just talked about. And on Express, we want to reduce executions during, or execution duration and reduce the memory. So these are the 2 things we're going to concentrate as we're going through that. So let's kind of walk through, again, the pricing. So you look at this kind of quasi-step function, and you've got a get item. So here you're going to pay for the operation. So we're talking about an application holistically, right? You're going to pay for DynamoDB read capacity units, right? Then you're going to have a transition. And then you're going to have a Lambda invocation. So you're going to pay for Lambda invocations outside the free tier. So you're looking at duration and memory configuration there. Then you have a transition, and then you have a put event, which again is part of EventBridge. It's going to affect the overall usage and cost. So there's some things directly in step functions that we can help to kind of reduce these. And the first one is step functions, intrinsic functions. Anybody using the intrinsic functions now? Okay, not a lot of you. Okay, okay. I really encourage you to look at this. And I'm going to show you a real simple one, but there's some more complex ones you can do. But let's say we have to generate a unique ID, which we do all the time, right? And so our standard go-to is UUID, v4, something like that. So we'll actually, what we'll do is in our step functions, we'll invoke a Lambda function that creates a UUID and returns a UUID. Anybody doing this pattern? Okay, a couple of you, all righty. I'm going to show you something. Right in step functions, the intrinsic is a function called states.uuid. And it happens in the ASL, and it doesn't cost you a transition, right? So you're saving invocations 1, and you're saving transition 2. So this is a very small example. You can get to very powerful transitions in the ASL, and even more so after an announcement a week ago that I'm going to get to in a few minutes. Right? So this is a way to reduce them. That, again, you save the invocations, you save the cost, you save less code to manage, and that's the big win, right? All right, so let's look at reducing transitions using the callback pattern. So we're going to go back to these guys. Right? So we have these looping that are going on. And again, what it's doing is it's literally saying, hey, is the approval happening? And then is the process done? So we're looking to see if those are done. And we don't know how many transitions is going to happen. It's just going to keep looping, going back and forth. So the next pattern I'm going to show you is what we call the emit and wait pattern. And this is really cool. It is only in standard workflows. And what this allows you to do is, I'll kind of walk you through it. So we have this emit, so we're going to send this out. We're going to send an event, we're going to drop it on EventBridge, and there's a rule that'll invoke a Lambda function, and it has a task token applied to it. And strangely enough, this task token is 1, 2, 3, 4, 5, 6, 7, 8. That doesn't happen all the time, but there you go. And so it saves that, and then either this Lambda function or maybe another Lambda function down later will actually, after the processing's done, it'll call back to the API on step functions, and it'll give us success or a fail. But the idea is it'll say, this either happened or didn't happen, you may continue, right? So it'll also, if I send it, let's say I can put the same process, but this time I've set a heartbeat. I've said, if I don't hear from that system in 20 seconds, at least a heartbeat, then it's a timeout. So what happens is our system times out and it ends it. So that keeps your step function from just hanging in the balance going, hey, are you done? Are you done? Are you done? So what you've done here is if we go back to our workflows, we're cutting out these looping processes, cutting out these transitions, excuse me, and we're replacing it with this task token call. All right, so let's look at our flow now. And it's looking a lot smaller, isn't it? We're still doing a lot of important things. So let's look at how this affects it. So the cost of parent workflow, so we've worked it down to 8 transitions now using this. So 8 times 1,000, again, the math. So now we've dropped another 10 cents per invocation, or I'm sorry, to run 1,000 of these. So 20 cents. So again, the number of state transitions, there's your cost differences. This is the nested workflow, same average duration, same price per. So you're looking at 20 cents per 1,000. Right, so we've cut it in half, or a little more than half. I'd say 49.732%, something like that. I'm just making that up. All right, so we've broken that out. So, but we're not done yet. So next thing we're going to do, in our nested transition, or in our nested state function, we're doing 4 transitions here. We're doing 4 Lambda functions invocations. We're updating order history, data warehouse, customer profile, and update inventory. Now, obviously, we can combine those into one Lambda function, but that's kind of might be, we're losing the single responsibility, right? So we want to keep those separate. We want to do error handling on just the one. But the systems that we're working on, like our data warehouse and our inventory service, these are third-party public endpoints that we're working on. We have an API. It's secure, but we're calling that to hit that. But again, it requires authentication. So what I'm able to do is I can use the HTTP endpoint transition, or task, I'm sorry, inside of step functions, and I can call that directly. And it uses the authorization inside of EventBridge. It uses an EventBridge connection to make this. So you set up your authorization, authentication, things like that, and then it uses that to talk to the third-party service, and there you go. So it sends that out. So now I've reduced this by 2, not transitions. I still have transitions, but 2 Lambda function invocations, right? So we're not going to do the cost of that because we don't know what it's doing. All right, so this is for HTTP API integrations that needs to be on public endpoints and stuff like that. But who saw the announcement last night about the resource endpoints? All right, okay. So I'm gonna show you something really cool. This is brand new. There's a thing called resource endpoints that allow you to share from in your VPC. You can share resources. Now, I'm not going to go into all the setting up on that. That's kind of out of scope for this. But it allows you to share a resource inside, outside your account, inside your org, outside your org. You're able to share those things. And then what happens is you can, with EventBridge, my connection can point to that resource. And then I can, from step functions, call to a resource and a VPC directly. Now, how you used to have to do it up until last night, about 10 o'clock at night last night, is you would use a Lambda function, you would call a Lambda function. Lambda function would have a VPC, it would be in the VPC, it would make the connection and return the data, right? You don't have to do that anymore. Now, there is some setup and configuration you need to manage with the resource endpoints, and there's a great blog about that I'm going to add to our resources page now that it's out. I'll add that a little later that Jeff Barr wrote that kind of walks through all that. But this is super powerful because 1, you're saving a Lambda invocation, and 2, it's just a configuration. You're going in and out of that. So super excited about that. All right, the next thing I'm really excited about, and this is something I've been working on, and hopefully you've seen these announcements, we're going to talk about improved data flow. And the first, there's 2 features that we released on the 21st of this month, actually the 22nd of this month, that make me want to just sing. I'm really, really excited about these. The first one is JSONATA support for data transformation. Really honestly, you should be so excited about that I can put down the hand and walk out. Because this is really amazing. Anybody using JSONATA now? Okay. How excited are you to see it as step functions? Yeah, that's what I want to talk about. Exactly, there we go. So JSONATA, if you're not familiar with it, is a powerful query and expression language to help you select and transform data in your workflows. When you set up your workflow, you can actually assign, you can say, look, I'm going to use JSONATA throughout this workflow, or I'm going to use it just on different areas. I don't know why you would do that, but you have the flexibility to do that. You can still use JSON path, but I'm going to show you why you probably don't want to. It's still great, still works, but I'm going to show you why this is the new default. So first of all, let's talk about the task state. All right, so how many of y'all, raise your hands honestly, you absolutely love that there are 5 different JSON objects you got to deal with? And who really understands? I think one person, there's someone in here from Grant over here, I'm going to call you out. Grant heads a whole team that build amazing step function stuff. Maybe he understands it. But it's tough to understand what is input path versus parameter versus result selector versus result path versus output path. Right, so we struggle with that. Well, in the new JSONATA setup, all you have is arguments and output. And that's it. Yeah, that's worth it. So arguments and output. Arguments before the task or workflow, and then the output that comes out of that. Super powerful. Also, we've changed the syntax. So in this, look at there. There's no $. It's gone. There's no $. Who knows when to use $$ versus $$? Okay, nobody, right? Yeah, it's a try it and see if you get what you think you're going to get, right? Honestly, $$ is context, but there you go. I'm just saying that because someone said it to me, right? So in all honesty, all right, so this is what the syntax looks like. We drop the $. It's no longer there, right? And then we wrap the JSONata in a curly Q %, and then I'm using the states.input.firstName. Now, this probably looks different to you, right? Because this is a variable, which we're going to get to. I'm kind of spoiling it here, right? So the states variable, states.input, gives you the input. You can get the results. You can get the context, all through the states variable, right? So this is what the syntax looks like. These are the reserved variables. I was just alluding to that. So the states.input is the raw input to the state. The states.result is the result from the state if successful. The error output, obviously, if it wasn't successful, which I never see that, so I don't know. So, yeah, there you go. And then the context object. So when you want context, you just say context, right? Not $. Is it $3? Maybe $5. I don't know. All right. So the next thing you get is you get a whole set of JSONata functions. This isn't all of them. This is all I can fit on the screen, right? So you have the string functions, number functions, numeric aggregation functions, all those kinds of things, and a lot more. But additionally, we've given you a replacement for the intrinsic functions. Right, we have the partition, we have range, hash, random, UUID. Stop going to Lambda functions for UUID. Do it right in JSONata. Right? And then you have the parse. Super excited about this. I'm going to show you a little bit of example, just some real basic ones. Anybody seen us use s12d.com as our URL shortener? We use it all over the place. You'll see links, S12D. So that's actually built with just API Gateway and DynamoDB and VTL. I was really mad at myself one day, so I decided I would build that with VTL. So there you go, and that's a whole other story. But we run a lot of these, and so sometimes we have to change owners. So we run the old owner, we have to update it to a new owner. So this is what it looks like in the update record for the DynamoDB. So the first thing is, I do a scan. So in this, I have to scan the whole, I'm doing a scan. Yes, I am, but it's intentional. I have to scan the database and get all the records, and I grab out of that, I want the ID. So the states.input.id. The next thing I want to grab is down below is I want to actually insert a today's date, right? Now, before I might have to go out to a Lambda function, or I might try to grab it from the API context. I might do some wizardry with all kinds of things. Now I just simply have the now in JSONata, and you get the timestamp, okay? And then I'm also using a variable here, a variable that I set up before, and called the new owner, and then I can insert that. So I'm not having to go, $.results. Where was that located? I have forgotten. New owner, right? Okay, so we'll climb into that in just a minute. Here's another one that I'm that I was super proud of. One of the things is when we make this change, I wanted to output a change set. I have an array of records that have a lot of data, but I really just need the change data, and I need a change set. So what I'm able to do is I have a variable called records that I created that I update as I'm looping through. I append to that using JSONata, and then I can map this doing the dot and then the bracket there, or the curly bracket, and I say I want the ID, I want the old owner, I want the new owner, and that's it. Get rid of everything else. And I don't have to write a looping transition. I don't have to do anything like that. I just map through with JSONata, and what happens is then I get a whole set of these records on the left pared down to simple records like this on the right without having to leave the transition. It's done right in ASL. And that's just a quick intro to JSONata. There's a lot more you can do with that. It's super powerful. All right, so last year we were talking about, when we go through this, we say we preserve data without map state. There's really no concept of a variable, so you would have to pass it from state to state to state. How many of y'all love that? Okay, all righty. And it's here that I would show you a really cool pattern that actually Ben Smith showed me, where you would actually do a parallel and save the parameters in a parallel. But still, you got to know the array, where is it in the array, the index, that kind of stuff. Well, that has changed. We now have, step function has the concept of a variable in step functions workflow variables. All right, so this is a really cool process that works hand in hand with JSONata. It does support JSON path as well, so you can use both. So let's talk about how these work, right? So assignment looks like this. You have a new object. This is what it looks like in the ASL. You'll also have a tab that's the arguments tab. And this is, I'm sorry, the variables tab. And this is where you'll assign it. Like my old owner that I was using, I want states.input.oldowner. My new owner, states.input.newowner. And then a table is just a hard-coded string. And then to reference these, you actually have the $ table. And that's it. No dot, no anything like that, just $ table, and that's the variable name. Super cool. Yes, thank you. Yes, I didn't make it, but I am absolutely taking credit. So out in the real world, I tweeted I made this. So no, all honesty, the step function team is just killing it. I'm super proud of them, and they're going to town. Right? So this is how you would reference those. But I want to explain the evaluation order. This is really important. It tricked me at first, right? So we're going to look at in JSON path if you're using that. So the actual task or workflow runs before you assign a variable. So the $ that you're getting there is the results of that variable. So that's really important to understand, and I'll explain kind of the ramifications of that shortly. So that's what it looks like if you have an error, same thing. So that's, if it errors out, you get that. And then of course, with JSONata, when you just have arguments, it again runs after the workflow, so it's at the same time as you're doing output, you assign the variables, right? So what that means is that there's some scoping you need to understand here. So the first thing I would say is if you assign something, if you want to assign something so it's top level, whatever task this is, it will not be available in that task. Right? So if you assign a variable and then you try to reference it in the same task you're assigning in, it won't work. So if you got something coming in that you need to assign and use, then you just use it in both places, but not as a variable. Right? But it will be available in subsequent tasks as you're going down. So it's available here and in child scopes like parallel. So you have an outer scope and an inner scope. So this is important to understand. Right? Inline map. Distributed map, it will not be available because you're leaving the step function. You're actually generating a new step function or a nested step function. This will be the same with nested step functions that you manually do. Right? So these will not be available. That's really important to understand. So this child scope, there's also the idea of a sibling scope. Right? So let's say we have a parallel that has 2 branches in it, and I assign it on the top left and whatever I'm doing. Maybe it's a DynamoDB call, step or Lambda call, something like that, invocation. It will be available in subsequent tasks under that on the left side, but not on the right side, okay? Because these are 2 different branches, so really important to understand. It also will not be available outside the child scope, all right? So these are just some things to understand. I have a video out there that explains this as well. So again, you could pass into a child scope, but you cannot pass out of a child scope. There you go. But you can reset it, as you need to afterwards. Okay, so that's workflow variable, and I've been building with this for about the last month, and it's like, oh my gosh, this is so easy. This is really cool. I really encourage you to go take a look at that. We'll be adding patterns in serverless land, things like that. All right, so let's get into managing failures, all right? So there's this good-looking chap here. He's got the same hair I do. He said, everything fails all the time. This is a very famous quote. We've probably all heard it. The reality of, though, is it's true. Right, we deal with this. It's hard to tell. It's hard to do a session that doesn't have this, and the reality is true. Right, everything fails all the time. So, how do we handle failures? I'm going to give you a couple of patterns. The first one we have is the saga pattern. Right, so if you have multiple transactions that need to happen, you need to catch those. And this is the way this works in step functions. So I'm going to book a hotel in a happy path when everything's working. I book a hotel, I book a flight, I book a car, I end it, I'm good. Everything worked. But what happens if the book hotel fails? Well, then we catch it and we cancel any work that's been done, all right? What happens if we book the hotel, but we fail to book the flight? Well, and this is really interesting. We actually cancel the flight and we cancel the hotel because this is all combined and connected. Finally, same process. If we book a car, everything else worked. If we book a car didn't, we cancel any part of the car in a catch. We cancel the flight, we cancel the hotel, and we've kept the customer clean. He doesn't have partial orders somewhere. So that is the saga. The other one that works here is really handy is the circuit breaker in step functions. And these aren't new patterns necessarily, but how they work in step functions. Anybody use this pattern now? All right, cool, very cool. All right, so the way this works is you're gonna get, when you run this in a success case, you're gonna get a circuit status. Circuit, I say circus every time. So we'll go with that. And it'll check, is the circuit closed? Yes, it's closed, so that's good. So we'll go ahead and run the Lambda function, and the circuit's closed, and we're good. So everything went well, didn't have to do the catch, we're all good. We're gonna run it again, and we say, get the circuit status, it is open. I'm sorry, it's open, or I'm said it again. It's closed, so we're gonna go back to the Lambda function. However, the Lambda function fails. So even though we thought it was working, it wasn't, so we need to update this. So we actually update the circuit status to be open, so it's broken right now. So the next time we run it, it'll check, the circuit is open, and so we're just gonna go ahead and exit out, right? So this is a way of managing, especially third parties, things you don't have control of. If it's down, you get to work with it. All right, so that's the circuit breaker. A couple of failures. Okay, so when we're building things, we learn from failures, right? I can't tell you how many times. I mean, how many of y'all are the developer that just tries until it works? And then you don't know why it works? That's me. Yeah, I hate that. It's like, well, why is it working? What'd you do? I was like, well, the X was in the dot, and then it was $3 signs, so that was my bad. I don't know why it's working. It just worked. Was it going to work next time? I don't know. That's how it goes, right? So last year we built a service called the serverless videos, kind of like another serverless espresso. And we were building it. It's a video processing. We wanted to show people that, hey, you can process video with serverless. It can be done. So one of the things we were doing is we were actually processing videos in a Lambda function. We're processing streaming files to MP4. And if the Lambda failed because we ran into timing issues, maybe it'd take longer than 15 minutes. Maybe we needed more memory, those kinds of things. Well, then we could eject and we could actually spin up an ECS task, right? So we were learning, okay, that doesn't work. So we got to think about it, okay, that doesn't make sense. But if it fails, we run it through an ECS task and everything goes just fine. But what if we could find some metadata that told us when that breakpoint happened? So in this, we literally just said, hey, if it's longer than 20 minutes, that seemed to be where it was for us, then we could actually run it to ECS and or run it to a Lambda. How many of y'all know that you can actually start up an ECS task, run it, and shut it down from step functions? Okay, and it's done event-driven. So you don't pay for the ECS until you're using it. We're going to be talking about this. I'm actually doing a session tomorrow, event-driven architectures with ECS Fargate. So it's really interesting how that happens. Okay, I think I accidentally hit the button there, but that's all right. So in this, it's really cool. So we have the Lambda that runs. It's the same code, right? We run in a handler. The other will run in a function in main. All right, so how that works is there's no need to wait for long-run tasks to rerun. I'm sorry, this is the redrive. If you're not using a redrive, this is a feature we released a while back. What this allows you to do is when you hit a problem, so we're doing our video process, but we want to persist the metadata, and it crashed. We don't want to rerun everything. We don't want to pay for all that. We just want to redrive this. So we can actually go to this state and say, run this, and then only charge me for what's left. So it's super handy, works great. Along with that is the test state, right? So I can actually go to that and I can test it just by itself. So it's only that part, and this is what it looks like. I can go in the console, I can say, all right, use this data, this is some dummy data or real data, test this and tell me tell me what's wrong. I can fix it, then once I have it working, then we're good to go, right? All right, so let's talk about managing failures. Let's talk about step functions at scale. And we're going to talk about parallel invocations. So parallel invocations, this is a pattern that we see some people use, but they're not using it to its fullest, so we'll talk through this. It's lots of independent workflows doing their own thing. So in parallel invocations, you have the same ASL executing at the same time. So we're going to say, all right, here's your code, and I want to do a bunch of different things. And maybe it's different things, but they run in parallel, right? And so a parallel state executes a fixed number of branches in parallel. So you can say, look up the zip and look up the number. So if they both go through, everything's fine. If one fails, the whole state fails, right? So even the left side fails, you get an error. So in these, you want to build in a catch that catches that, and then the whole thing will be successful. So you can continue it on. So you kind of decide, do I want the whole thing to fail, or am I okay just allowing the phone number not to be looked up, something like that. Dynamic parallelism is a little different. Dynamic says we're going to run the same thing across as many as you want. So if you have an array of data, we're going to do it for each one, as much as you want, right? So here's an example of this that we actually use, and this is a pattern we call the big fan, or the fan-out pattern, where we actually get blogs. So we're going to do a blog post where we scan the RSS feed in Google, right? I'm sorry, in our blog's compute feed. And it catches all that, and then returns an array of new compute blogs for posts. So this is what that looks like. For each one of these, we go in and we get some data, and then we save it back to GitHub, right? So when all is done, then we rebuild the front end, and that's serverless land. That's how we do some of the blogs in serverless land. We automate a lot of this. But sometimes, not necessarily GitHub, but sometimes you run into your downstream can't handle, if I'm using dynamic parallelism step functions, it's going to be very fast, right? It's going to do a lot, and maybe it can't handle it. We use a couple APIs internally that are not AWS APIs, they're third parties, that I have to throttle, right? So I need a little control over that, so I'm actually going to use the scatter gather and try not to hit GitHub over and over. So it's the same process where I'm going to go and get the new blogs, and then when I come into the metadata, I'm going to scrape the metadata, and I'm going to gather this all into an array. The parallel kicks it out into an array, and then I'll do one push to GitHub, and there you go. But the most powerful one we have is the distributed map state. Anybody use distributed now? Okay, I know you all are. A lot of you are. Okay, distributed map state says we're going to create as many as you want, up to thousands upon the tens of thousands, and we're going to run them in nested workflows. And there's a couple advantages of this. You're going to break out, like, anybody run into the history problem where you got too much history? It's like, oh. And then you spend time trying to make your content smaller, but that's not really what it is, it's history, right? So by doing this, you get around that by the histories at each nested workflow, right? So let's look at an example of how this works. So this is a serverless GIF animator. There is the awesome Ben Smith. He built this, where you converted an MP4 from Amazon S3 into multiple GIFs. Here's how it works. So we start it, we pass a file name, and we pass a location. It's going to go in, the Lambda function calculates chunks. It says, here's how many, and it dumps those into an S3 bucket. And then we point our dynamic map at it, and it says, hey, here's a JSON object. When this JSON object hits, we want you to iterate over this JSON object, right? And so then it spins up in every one of these, that Lambda function processes just that little section that it has. You're supposed to do from 0 to 29. The next one does from 30 to 59, and so on, right? And then it drops it all out in a bucket. So what happens is, let's say you have a 400-minute file that you want to run. That's many hours of data. You drop it in here, and it breaks it into 30-second chunks, so we're going to have 800 lambdas come up and do it, right? If my math is right. And it does it instantly. Boom, done, drop it in. And then the result is you get a GIF, okay? Ben doing thumbs. I left Ben in because I don't have thumbs, so you understand. Okay, all right, that's on video. Sorry, Mom. Okay, all right, so that's what you get with that. So you, again, using the distributed map, you get around the concurrent executions, you get around the, and then the history, things like that. Each iteration runs as a separate child workflow, which I was saying. So let's see what happens without that, right? So an application pulls, so we're doing back to our GitHub, it pulls GitHub each day, and we run this separate. This is without it, right? A map says currently, and we get that error. We get errors where we're getting too much, our objects are getting too big, history's getting too big, things like that. But when we break that out separately, we can use this pattern called the payload divider, where we actually say, okay, we're gonna scan for the parents, we do the distributed map for each parent. So again, we're gonna scale out to different ones. Inside of there, they're gonna run another inline that scans, and now you don't have history problems at all. All right, so this So that's kind of the end of the advanced workflows. Hopefully I taught you something that works. This and a lot of other patterns are on the serverless workflow collection. I encourage you to check it out. The way we do this is we make a visual for it, we make an IAC template for it, and we make an ASL definition. I've made a lot of things I talked about are in a resource page that I've put here, s12d.com, API 402-24, or you can scan the QR code. I'll leave that up for just a few moments. Grab that. If you don't see it, I know we're sharing these decks later. So, in fact, it's shared inside of this resource page. So if you'll get the resource page, you can get the link to the resource page. Good luck. All right, so that's a chicken and egg right there. I challenge you to continue your AWS learning. We have a lot on serverless that we want to help you with. And here's a couple other sessions. We have one later today, the AWS Step Functions Workshop. This is great if you're learning step functions. And finally, upgrade your game storyboards that are using step functions for this. And with that, I'm going to say thank you. I really appreciate you taking the time to come and see me. I hope you have a fabulous reInvent. Have a good day. Thank you.